Have you ever stopped to wonder about the nature of reality? It's a big question, one that keeps philosophers and scientists up at night. Some of the most intriguing ideas sound like they come straight from science fiction, but when you look at the evidence, you have to consider them. What if everything we see, everything we touch, everything we know, is actually part of a massive, sophisticated computer simulation? Think about it like an incredibly advanced video game. We are the characters inside that game. We are living out our lives according to a set of pre-programmed rules. The laws of physics, like gravity and electromagnetism, might just be the underlying code that governs our simulated universe. To understand this idea, we need to talk about something called error-correcting codes. Imagine you're sending a message, like a text or an email. Sometimes data gets corrupted along the way. A 1 might accidentally flip to a 0. To prevent this, computers use special codes. They add extra, redundant bits of information to the original message. These extra bits allow the receiving computer to detect if an error occurred, and more importantly, to fix it automatically. It's like sending a note that says, "The cat sat on the mat." 10 words. The word count is the extra data that helps verify the message is complete and correct. This is a fundamental part of keeping our digital world running smoothly and accurately. Here's where it gets really interesting. A theoretical physicist named James Gates Jr. made a startling discovery. While working with complex equations from a field called supersymmetry, he found what looks like error-correcting codes embedded deep within the fabric of reality itself. Specifically, he found a type of code used in web browsers and data transmission. To find the exact same kind of code that we humans invented for our computers, but written into the mathematical laws that describe how particles and forces work, is mind-boggling. It strongly suggests that the rules governing our universe might have some digital properties. Why is this discovery so important? Well, if the universe is just a natural phenomenon, a product of random chance and physical laws, you wouldn't expect to find something so specific and frankly, artificial looking. Error-correcting codes are a hallmark of intelligent design. They are a solution to a problem that only exists in information processing systems. Finding them in the math that describes our reality is like finding a computer chip in an ancient rock formation. It doesn't prove we live in a simulation, of course, but it's a compelling piece of evidence that makes you scratch your head and say, that's peculiar. It forces us to ask if there's more to reality than meets the eye. Let's look at the universe from a different angle. When astronomers map the large-scale structure of the cosmos, what do they see? They see galaxies aren't scattered randomly, they are arranged in a vast interconnected network. There are long filaments of galactic superclusters separated by immense empty voids. This structure is often called the cosmic web. It's a beautiful, intricate pattern that stretches across billions of light-years. The sheer scale and complexity of this web are awe-inspiring. It's the grandest structure we know of, and it holds clues about the universe's origins and its ultimate fate. It's the backbone of everything. Now let's zoom way down. Let's look inside the human brain. Neuroscientists have mapped the connections between brain cells, or neurons, and what does that network look like? It looks remarkably similar to the cosmic web. You have neurons connected by long filaments called axons, separated by empty spaces. The pattern of connectivity, the way information flows, the sheer structural resemblance between a single brain cell's network and the entire universe's network is uncanny. This has led some people to wonder if this is just a coincidence or if it hints at something deeper. Is the universe itself a kind of thinking entity? This brings us to the idea of a mirrored reality. Imagine our universe is a shadow, it's a reflection or a simulacrum of a higher dimensional reality that we can't directly perceive. Think about it this way, a two-dimensional being living on a flat piece of paper could only see lines and shapes. They could never comprehend a three-dimensional object like a sphere passing through their world. To them, it would just appear as a circle that grows and then shrinks. Our three-dimensional reality could be just like that, a lower dimensional projection of a much more complex, higher dimensional existence. We're living in the copy, not the original. What would this mean for us? It would mean that our reality is fundamentally based on something else. The source code for our universe, so to speak, would exist in that higher dimension. The patterns we see, like the similarity between the cosmic web and a brain cell, might not be a coincidence at all. They might be a direct consequence of our universe being a reflection of that larger, more complex structure. Our universe could be a single thought or a single cell within a much grander cosmic brain. This is a mind-bending concept that challenges our very definition of what is real. If we follow this line of thinking, where does it lead? If our universe is a sophisticated simulation, then there must be a computer running it. And that computer would need an operator, a controller. This is where a classic concept gets a modern technological twist. The idea of God could be reimagined not as a mystical being in the clouds, but as the ultimate quantum computer controller. This entity wouldn't be judging us from a throne, it would be the master programmer, the system architect, the one who initiates, observes, and maintains the simulation we call reality. It's a way of merging science and spirituality. In this model, God isn't a person, it's a process. It's the intelligence behind the operating system of the cosmos. This God computer would be responsible for setting the initial conditions of the Big Bang. It would define the fundamental constants of physics, like the speed of light and the strength of gravity. These aren't just random numbers, they are the finely tuned parameters of the simulation, set just right to allow for the emergence of complexity, stars, planets, and life. Any slight change to these parameters, and the universe as we know it would cease to exist. The controller set the dials perfectly. Now let's take it one step further. Many ancient traditions speak of divine helpers or aspects of a single creator. The Bible, for instance, talks about the 7 spirits of God. What could these be in our simulation model? They could be thought of as specialized program administrators. Imagine a massive software project like our universe. You wouldn't have just one programmer, you'd have a team. Each of these 7 spirits could be a master administrative program, a core subroutine with a specific crucial function to keep the simulation running smoothly and according to the grand design. Each spirit or administrator would have its domain. One might be the spirit of wisdom, in charge of the logical consistency of the physical laws. Another could be the spirit of understanding, managing the flow of information and causality. You could have a spirit of power, governing the energy dynamics of the cosmos, from star formation to quantum fluctuations. The spirit of knowledge could be the master database, the Akashic records of everything that has ever happened. This framework provides a fascinating way to interpret ancient spiritual ideas through a modern, computational lens, giving them new meaning in our digital age. So, where does all this leave us? We've journeyed from error-correcting codes in the laws of physics to the universe as a giant brain cell. We've considered reality as a shadow of a higher dimension. And we've imagined God as a quantum computer operator with 7 administrative programs. These are not mainstream scientific theories, of course. They live on the speculative edge of physics, philosophy, and metaphysics. They are thought experiments designed to push the boundaries of our understanding and to challenge our assumptions about what is real. They are what make science fun. The beauty of these ideas is that they spark curiosity. They make us look up at the night sky with a renewed sense of wonder. Are those stars just massive balls of burning gas? Or are they pixels on a cosmic screen? Is the pull of gravity a fundamental force of nature? Or is it a line of code in a program of unimaginable complexity? We don't have the answers, and maybe we never will. But the act of asking the questions is what drives us forward. It's the engine of discovery, the very thing that separates us from the other creatures on this planet. Ultimately, whether we live in a simulation or a base reality might not even matter to our daily lives. We still have to wake up, go to work, and be kind to each other. But entertaining the possibility expands our perspective. It encourages us to think critically, to question what we're told, and to remain open to possibilities that seem impossible at first glance. It reminds us that the universe is far more mysterious and magnificent than we can possibly imagine. The quest for knowledge is a journey, not a destination, and there are always new doors to open. So, the next time you look at the world around you, take a moment. Consider the intricate patterns, the unwavering laws, the sheer improbability of it all. Is it all just a happy accident? Or are you a player in the most epic game ever conceived? The truth is out there waiting for us to find it, and the search for it is the greatest adventure of all. Keep looking up, keep asking questions, and never lose your cosmic curiosity. That's how we make progress. That's how we explore the cosmos, both outside of us and within.